Welcome to a course on calculus. Let us see first what does calculus mean? Where does calculus arise? What are we going to see in calculus? Right? So initially let us start with what do we mean by calculus. Whenever we hear of the word calculus, the two things that comes to our mind is always differential calculus and integral calculus, right? So these two primarily deals with what? These two things primarily deals with tangent problem and area problem. What is this tangent problem? Suppose you have a curve and you will have to find out the tangent at a particular point. How are we going to find it? Right? This is the basic tangent problem that we have. Right? And the area problem is all about finding the area of a particular, finding the area of a region under a particular curve in the given region. That is, we need to identify this area. And here you don't know what exactly, you don't know the curve behavior, and here also you don't know how to find this area because this is some unknown curve and this is some unknown shape, so you don't know how to find these things, right? These are the basic things by which calculus arose, right? So in calculus we are going to deal these two things, but these two things are forms of limits, right? So in order to study calculus, we must be clear with what do we know by limits, right? We have to be clear with limits, and once we study about limits, then we will of course come to the concept of continuity. Okay, these two things play a very major role in studying these two things, that is differential calculus and integral calculus. For these things, this is the basic. So in calculus, we will start with what do we mean by a limits, right? Limits are defined for functions. So function, in the sense, we will take y is equal to some f of x, where x is the independent variable and f is some rule which maps every element in the domain to the codomain, and y is here the dependent variable. So whenever you plot this as a function, right, this represents your x-axis and this represents your y-axis, which means the curve is your f of x. This is your curve y. Okay, here what do we mean by a limit? That is the question. Suppose I have f of x is equal to x square minus 16 upon x minus 4, right? I need to find out the limit of this function when my x approach 4. Okay, maybe in our school we are all taught that whenever you are asked to find out the limits, you will substitute x equals 4 in that place, and we will see what happens. And if some anonymous things happen, then we have certain rules through which we evaluate limits. That is of course there, right? But what do we mean by limit? Here we are saying x approaches 4. Okay, in the real line, okay, let this be 0, infinity and minus infinity, let this be 4. Okay, we are saying our x value approach 4. Okay, maybe here we may plot. Okay, my x is approaching 4, right? It means my x value is coming near to 4. I don't know from where it is coming. That is part, right? So my x value may come from this direction or from this direction. These two possibilities are there, right? So whenever your x approaches from this side and is going to exist, then we call that limit as left limit, left hand limit or simply left limit. Okay, when this thing happening in the right hand side, we say it is right hand limit. Okay, sometimes to a function this may exist, these two may be different, but whenever we say limit exists at a particular point, both left limit and right limit must be same. Right? Okay, we have technically seen these things, the names, but we have not seen what exactly it is, right? So now for this case, first let us give x is let us talk about left hand limit. Okay, let us take x equals 3. When we take x equals 3, what is my f of 3? That we will see. So it is going to be 9 minus 16 upon 3 minus 4. It is going to be what? Minus 7 upon minus 1, which is 7. Okay. Then we will take x equals 3.5. And you may see in the screen then what happens when x is 3.5. Then x is 3.8. X is 3.9. X is 3.99. X is 3.999. And I am keep increasing the value so that it is nearing to x. Now I have 3.9999. What happens here? The value is approaching near 8. So what can we say? When my limit x from left, in the sense it is some value which is less than 4. Okay, so we denote it by 4 minus. So limit x approaches 4 minus f of x is approximately 8. Right? Similarly, we see for when x is 5, my f of 5 is going to be what? It is 25 minus 16 upon 5 minus 4. It is going to be 9 upon 1, which is 9. Okay. Then let us take f of 4.5, f of 4.8, f of 4.9, we have to reduce the values, right? So f of 4.5, f of 4.3, f of 4.1, f of 4.01, f of 4.00001, and you may notice that this is also approximately equals 8, and hence we say limit x approaches 4 plus, since it is right limit. Okay, it is coming from the right, which means it is 4 with some extra quantity. So this quantity is also approximately equals 8. When left limit and right limit exist and they are equal, then we say limit x approaches 4, f of x is 8. Right? It is not necessary that the limit must always exist. There may be some situation where limit need not exist. For example, let us consider the function x upon 1 minus x. Okay, the function that we are going to consider is x upon 1 minus x. Okay, here what is happening? Okay, let us talk about limit x approaches 1 of f of x. Right? Here also we will have to see 1 minus of f of x and 1 plus of f of x. Let us start with x equals 0. Let us come from the left first. So when I take x equals 0, my f of x is going to be 0 upon 1 minus 0. It is going to be simply 0. When I take x is 0.5, it is what? F of x is equal to 0.5 upon 0.5 and is 1. When I take x is 0.75, my f of x is 0.75 upon 1 minus 0.75, it is going to be 3. when I take x is 0.9, my f of x is 0.9 upon 0.1, so it is going to be 9. Now when I take x is 0.999, my f of x is going to be 0.999 upon 0.001, right? So this is going to be 999, and if I make this value even bigger and it is nearing 1, we may see that f of x value is becoming large and large. It is not tending to a particular point, it is growing anonymously. And similarly, let us look from the right. Okay, when we take x is 2, f of 2 is what? 2 upon 1 minus 2, it is going to be minus 2, right? When x is 1.5, it is 1.5 upon minus 0.5, so it is going to be minus 3. F of 1.25 means 1.25 upon minus 0.25, it is going to be what? Minus 5. F is 1.1 in the sense 1.1 upon minus 0.1, so it is going to be minus 11. Here, make this value even smaller. Here what are you going to get? You are going to get some value which is smaller than minus 11 also. Right? In this case, what is happening? It is growing anonymously in the negative direction. Right? So, your left limit as well as right limit. Your left limit is growing anonymously in a positive direction, hence you are going to get this as infinity. Whereas in the right, what you are getting? It is growing anonymously in the negative direction, hence you are going to get minus infinity. You get your left limit to be plus infinity and the right limit to be minus infinity, and hence this limit does not exist. Okay. Basically, mathematically we have seen what the limits are and all these stuff. Okay, fine. Limits are the fundamentals to study the differential and integral calculus. That is why we are studying these things. Are there any physical significance to limits? Yes, of course we have some physical significance to limits. Okay. What does this limit mean literally? This means this is the best prediction of a point that we make. Right? Here you don't know exactly what happened, right? But for the previous problem, that is when your f of x was given to be x square minus 16 upon x minus 4, you approximated limit x approaches 4 f of x as 8. Right? This was the best approximation that we could make. Right? And this is some approximation that we are making. How can we be sure that this approximation is correct? We do not have any method to justify our approximation is correct. It is just a trial and error. Right? How do we see it? We were able to plot these things in a graph. Right? Suppose you are going to talk about the limit at this point, so you will talk about this thing. Right? This may be your f of x literally, but your suppose, okay, let us take this as x1, this as f of x1. Your limit x approaches x1 of f of x need not always equal to f of x1, because when you substitute x is equal to 4 in this case, what are you going to get? Your f of 4 is 4 square minus 16 upon 4 minus 4, it is 0 upon 0, which is an indeterminate form. This is not equal to 8, right? So, the point that I am trying to convey here is, you have a point, right? So, if you try to zoom it as possible around the neighborhood of this point, the approximation stays the same within the error limit that we specify. Do we need to check about error as well? Yes, of course. here during these calculations I said this is approximately equals 8 and that is approximately equals 8, and hence we conclude this limit is 8, right? This may be 7.99999. 7.59s are there. I approximated it as 8, which means I have admitted the error of 10 power minus 5. Supposing I am going to admit error of 10 power minus 15, I will have to look till that. It means, literally it means I will have to zoom in the graph as much as possible so that my in the scaling, okay, suppose I am looking at the scale. The scale means simply if we have 1 centimeter in the sense, then I will have to look for 10 power minus 5 in the sense this has to be 10 power minus 5 centimeter. It is what? 0.00001 centimeter. This is the accuracy I am fixing. This quantity must be this. If I am deciding for 10 power minus 8, then it has to be 0.00000001. This 1 unit must be this much centimeter. Even though I zoom till that, this has to stay accurate. That is what we mean by the limit. And are there functions for which limit do not exist? Yes, of course, we have seen one example, right? Limit need not always exist for all the functions. Okay, what is the need of looking at this limits? Suppose if I am going to consider a function that is my f of x is simply x squared, and I will have to check the limit of this function when my x approaches 3, it is going to be 9, right? I may look from the left or I may look from the right, and these calculations you may do, and you can identify that this is 9, and this is exactly same as that of f of 3, right? So what is happening here actually? That is something which happens, right? So limits will give, if this function is something different from the functions that we have seen already, right? So we have some black hole scenarios kind of things in mathematics. At those black hole scenarios, limits gives you the best approximate. What are those black hole scenarios? That is divide by 0. Okay, do we have divide by 0 category in the functions, in these functions? Of course, when your x is 1, you have divide by 0 category here, and when your x is 4, you have divide by 0 category here, right? And what is the next black hole scenario? That is growing infinitely, right? Here, thank God, here it does not happen, okay? Whereas here, when your 1 minus x is 0 or nearing 0, what is happening? It is growing infinitely, right? Sometimes, even though it grows infinitely, it may give you a limit. We will see such problems in the upcoming lectures. In order to handle these kind of black hole scenarios, we have limits in mathematics, right? Based on these things only, we are going to talk about the calculus things, right? Thank you for watching.